Okay, so now we're going to get a little bit of practice with rotational inertia. And we're going to do some where we have to use the table and some where we just add up all the mr squareds and find the sum of all those to get rotational inertia. So anyway, let's say that we have a unit or a massless rod, okay? And we're going to have two like chunks of clay hooked to the end, and we're going to rotate it. So we have this scenario, we're rotating about the center. In this scenario, we're rotating about one end. Okay, before we start, which of these two scenarios do you think is more difficult to rotate? Which one do you think has a greater moment of inertia? Alright, and so let's go ahead and calculate it now. So for the first one, we're going to add up all the mr squareds. And so for this one, it's m times 1/2 L squared. We're going to add to it m times 1/2 L squared. And so for each we get 1/4 ml squared. Okay, we add those two up and we get that the moment of inertia there is 1/2 ml squared. So that'd be the measurement of how difficult that guy is to rotate. So for this one, we've gone ahead and we're going to say, okay, well, instead of rotating about here, we're going to rotate about this end. Alright, and so I is equal to, the radius for that one is 0. And now this one has a moment of inertia now of ml squared. So it looks like this one is more difficult to rotate. Okay? Okay, so for this next one, we're going to find the rotational kinetic energy of this rotating, say it's a meter stick or something. It has an angular velocity of 5 radians per second. Let's say that it's a meter stick, so it has a length of 1 meter. Okay? And so we're going to say this is a uniform rod being rotated about its central axis. Okay? And we want to find its kinetic energy. The kinetic energy is going to be 1/2 I omega squared. Okay, we know that omega is equal to 5. We need to know what I is. Okay, well that's where our handy table comes in. So if we look for a thin rod about axis through the center perpendicular to the length, it says that we get 1/12 ml squared for the moment of inertia. So we're going to come back over to here and say, okay, well I is equal to 1/12 ml squared. Okay, so then K is equal to 1/2 times 1/12 ml squared times omega squared. Okay, so what we're going to do here, we're going to take 5 radians per second and put in for omega. So 1/2 1/12. Let's say it has a mass of 60 grams. That's about the mass of a meter stick. So that'd be 0.06 kilograms. Okay, so 1/12 times 0.06 times 1 meter. And then we're going to have 5 radians per second. We're going to square. Okay, this is kilograms, by the way. We're squaring this, that's meters. Let's pay careful attention to the units, see if we end up with joules. Okay, so 1/2 times 1/12 is 1/24 times 0.06 kilograms times 1 meter squared times 25 radians per second squared. Okay, I guess these would be radians squared per second squared. Doesn't matter because when you multiply by the 1 meter squared, this becomes 25 meters squared per second squared. Okay, times 0.06 kilograms, and this is all over 24. Okay, so we get 1.5 kilogram meters squared per second squared over 24, or 0.0625 And then a kilogram meter squared per second squared is a joule. Remember that kilogram meter per second squared is equal to a newton. And so we get a newton times a meter, which is equal to a joule. So this is 0.0625 joules. Okay? Rotational kinetic energy. Okay, we're going to do one last one here. We have a rotating disc. Okay, it's going to complete one rotation in 2 seconds. It's got a radius of 0.3 meters and a mass of 1 kilogram. And I want us to find its rotational kinetic energy, or 1/2 I omega squared. So we need to find omega, which is radians per second. We know that we have one rotation in 2 seconds, which is 2 pi radians in 2 seconds. And so we get pi radians per second. Okay? Now we need the moment of inertia. Okay, well, I'm not going to integrate again. Just going to look back at my table. Okay, and I see that for a, let's see, so this would be the cylinder, or we're just looking at the face right here. Okay, this face right here, and that's what you're going to usually be using. So this is going to be a really common one. So if you're looking at the rotation of that face, okay, so that's what we're going to use. So I is equal to then 1/2 mr squared. Okay, well, m is 1 kilogram, r is 0.3 meters. Okay, so now we can calculate it. 1/2 times, let's see, 0.3 squared, 0.09, so times 0.09 kilogram meter squared. Okay, so that's going to give us 0.045 kilogram meters squared. Okay, so I'm going to take this up here, 1/2 times 0.045 kilogram meters squared times our angular velocity of pi radians per second. I'll always put in 3.14 and which one is square. Okay, and we'll go ahead and punch it in. We punch it all in, we get about 0.22 joules. Okay, and there we go.